Welcome, everybody. I'm Holly Cummins. I work for Red Hat. I'm a senior principal engineer with Red Hat, and I live in the UK, but I'm originally Canadian. And when you think about England and Britain, what is there a lot of? Yes, well, yes, definitely, and fog as well. The British are very good at fog, and so my flight yesterday was nearly cancelled, and a bunch of flights were cancelled because of the fog. But another thing that they're very good at in England is tea, drinking lots and lots of tea. And I think the English firmly believe that there is no problem that can't be solved by having a cup of tea. And so it used to be that tea was a really important part of our software development lifecycle. It was, fundamental to the software test cycle. Because what would happen is, and actually in England we did this with tea. In the rest of the world, I think it's done with coffee, but it's a similar sort of principle, which is if you wanted to try your web application out, you didn't just start your web application and see what it did. You had to go through a deploy cycle, and then you had to go through a cycle of starting the application server. And this would take several minutes. So what are you going to do in that time? If you're in England, the answer is obvious. You're going to go get a cup of tea. So you go get your cup of tea, and then you come back and you see whether your stuff works. And of course, inevitably, the first time, it doesn't. So you try again with another cup of tea and it doesn't work. And you try again with another cup of tea and it still doesn't work. And then eventually you try again and it works, which is a great relief because by this time you've had 6 cups of tea and you can't actually take any more tea. So I always like to think, no matter what I'm doing, what problem are we trying to solve? What is the problem here? So here, the problem is tea. The slow feedback loop means that developers drink too much tea. Well, is that really a problem? Tea's kind of nice. Well, it is, and I think that there's other problems as well. Because these frameworks that we were using, they were verbose. There was a lot of boilerplate code that you had to write just to make an application or just to access the database or pretty much to do anything. So we have 2 problems. We have the tea problem, and then we have a typing problem, which is our programming models, they're so verbose that we just end up with all this repetitive boilerplate. And so then we can group those 2 into a third problem, which is the tedium problem. It's just tedious doing development. There's so much time spent waiting. So is that the only problem? Well, there's other problems. A while ago, some colleagues of mine in Red Hat Consulting got an email from someone, and he was sort of doing microservices development, and he was the CTO, so they'd given him this really nice laptop. But even with this really nice CTO level laptop, he couldn't actually bring up the stack because there was so many applications in this microservices architecture that his laptop would start smoking before he could actually get the application going and try it out. So instead of getting faster to start, the application had got slower to start than it was in the 2010s. But all of this is still all about local development. This is still all about us as developers. And as we all know, not necessarily everybody cares about developers and developer experience. So what about in production? Is everything okay in production? In production, it's actually worse. We heard a story recently it was an airline company, and they had a system for scheduling the maintenance for the planes. And it was a microservices architecture, of course. And so a single service might take perhaps half a core and perhaps a gig of RAM. And this was important, so they ran it with high availability. So they had 3 instances per service. And they had about 100 microservices. So you can see all of a sudden this is adding up to a lot of resources that are being used for this application. And the problem, I mean, there's all sorts of problems here, but the fundamental problem is that Java just wasn't really designed for the cloud. It wasn't designed for local development, apparently, and it definitely wasn't designed for the cloud. And you can see this when you compare it to some of the other application frameworks that, we could maybe be running. So something like Go, it's pretty compact. You can get really good deployment density with Go. Something like Node.js, it's not too bad. It's less bad than you might think. And then when you look at Java, it's really bloated. And all of that resource usage, it's not just that it's kind of annoying. It's actually expensive. There is a financial impact to this. So even if management don't necessarily care about developers, they definitely do start to care about the cost. So we've got three problems that we're trying to solve. We've got the T in the typing, and then we've got a third problem, which is treasure. You can see I was trying to come up with something that started with T. I didn't do a very good job, but this was my best attempt. So basically, by running our Java applications, we are creating lots of treasure for the cloud providers because these applications are just so expensive because their resource usage is so high. So why is this happening? Is Java a bad language? Was Java a bad idea? Well, no, definitely not. This is happening because there's a mismatch between what we need now in 2024 and what these frameworks and what the Java language was optimized for, which was a really different way of running applications. So what we used to optimize for was a world where we were running on-prem. We had dedicated hardware for our application, and so that hardware had been paid for, so it didn't really matter how much resource usage our application had because the hardware was there. And these processes, they were long-lived. So you might have your application up for 6 months. You might even have it up for a year. So deployment was this really rare special event. So how did you make updates to your application if you weren't deploying new versions of the application? Well, you tended to update it piecemeal. So you'd change this a little bit, and then you'd change another little bit, and then you'd rewire this. So it was all really optimized for late binding, for this kind of loose coupling within the application so that you could swap bits of the application out and you'd use reflection to connect to this library until you did this, and then it would connect to that library. So it was super, super dynamic to allow you to really change the application without restarting it. But is that what we want now? Or I don't think so. So can we do better? Yeah, we can, which is where Quarkus comes in. And just to sort of give you a bit of a spoiler of how much better we were able to do, you can see that Quarkus is now it's competing with Go, and it's way better than Node.js. And it's way, way better than the old way of running Java applications. So here, this is with Quarkus Native, which is running on GraalVM. We also see improvements just on JVM, so I'll come back to that. But one of the things that is really different in the cloud is in the cloud, applications tend to be a bit ephemeral. They're going to be started and stopped really often. And, so it's a bit like a light switch, right? You turn it off, you turn it on, you turn it off, you turn it on, and you do that partly because of how the cloud works, but also to save resources. And Java is traditionally not at all like a light switch historically, but we can fix that. So with Quarkus, if you have just a REST application, if you're running it the old way on your legacy cloud native application framework, it'll take 4 seconds to start. If you run it with Quarkus as a JVM application, a quarter of that time, a fifth of that time, under a second. If you run it with GraalVM, compiled with GraalVM to a native binary, it is like 15 milliseconds. It is tiny. It is so fast to start. So let's have a look at that. So what I've got here is I've got my native application. You can see I compiled it ahead of time because it took a minute to compile and you don't want to watch it compiling for a minute. But now that I've got it compiled, I can start it. So that was how I compiled it. And I can run that and it's up. So when I first joined the Quarkus team, I used to spend ages just doing that because it was so fun just to watch it start. And the first time I thought, wait a minute, did I do it right? And so we can go to the web and we can see that this is indeed running something. It's not just that I had a shell script that printed the Quarkus output script. So I can go to localhost 8080 and let's go to hello. And there we've got application. Actually, that's the wrong application. That is not the one that I just started, but you can believe me that this could be the one that I've just started. So let's go back, and that's all right. I did a talk recently, and I think I was about 5 minutes in before someone in the audience put up their hand and said, Holly, we can't actually see anything at all. Oh, yeah, oops. So yeah, just to reiterate, run it with -p native, and you've got a GraalVM application. And I did some benchmarking. It actually starts faster than a light bulb. Not only does it start faster than like one of the old fluorescent light bulbs that take forever to start, it actually starts faster than an LED light bulb because an LED light bulb does have a startup time. Quarkus is faster than that. But the next question is, okay, well, that's very nice. That's a good party trick. Does startup time actually matter? I think it does, because what it means is that if you have auto-scaling on your application, you can run it much closer to the wire in terms of resource usage and scale it up in response to demand because it scales up so quickly. But there's other benefits of Quarkus. One of them is memory footprint. So the memory footprint is way, way smaller. So that means you can have way more of these applications running before your system runs out of memory. So in the cloud, you can pack them tighter. If you're running locally, that has some advantages as well. Before I joined the Quarkus team, I heard a story from about one of my colleagues, and I'm not actually sure which colleague it is, but I think they were maybe a project manager, something not super technical. And they were at a conference, and they had a Red Hat booth, and so then people would come by and they would show them Quarkus, and so someone would come by, you'd show them Quarkus, someone else would come by, show them Quarkus, someone else would come by, show them Quarkus, and only at the end did he realize he kept starting Quarkus and he never actually thought to shut it down. And at the end, he had 120 instances of Quarkus running on his laptop. And it was fine. It didn't matter. Everything just kept working because the footprint is so small. But then, again, the question is, well, okay, but do I actually care about memory footprint? I think in most cases you probably do, because the way cloud billing works really is that memory footprint is money. If you can run on a smaller instance, that's going to be a savings. And so for that airline scheduling application that I mentioned at the beginning, they were able to get 3 times denser deployments with Quarkus, and that was without sacrificing availability or response time or anything else. Another thing about Quarkus that doesn't get mentioned all the time that I wished we talked about more is it's not just startup time and memory footprint, it's also throughput. Quarkus has a faster throughput. So again, with Quarkus native, you might have about 3,000 requests per second. So with your traditional cloud native stack, a bit more than that. And then with Quarkus on JVM, it is a lot more than that. So these are our numbers, but this is something that we tend to see when people do this kind of benchmarking. So this was an article that appeared recently, and they had, again, sort of the response time with Quarkus was like maybe 15% of what the response time was without Quarkus. And the throughput was way, way higher as well. And so this, this is really good because when you have that higher throughput, when you have that lower response time, that makes users happy, which is usually the foundation of the business. So at this point, it seems a little bit like, wait a minute, so it's faster and it's lighter. Like, isn't that something for nothing? And I will get to that. Yeah. So yeah, that is certainly one thing. You We find people's porting experiences is pretty good, but you're right. There is going to be a process of moving. But more generally, I think there's kind of two ways that you can improve performance. And performance engineers often what they're doing is they're just trading off one thing against another. But the holy grail for performance engineering is when you eliminate waste. You find something that you didn't need to be doing and you get rid of it. And I think you can see both of those in this chart. So when you look at the GraalVM application, you can see it's amazing for its footprint. It's amazing for its startup time. The throughput is a bit lower. Um, on the other hand, when you look comparing it to your legacy framework, there's no trade-off. There's just better, except for, as you say, the trade-off of moving. So what was the waste that got eliminated? Like I mentioned, application frameworks used to be really heavily optimized to be as dynamic as possible. But that dynamism, it has a cost. So this is another T actually. You're paying a tax for this dynamism, even if your application isn't using it at all. That cost is just baked into the way that old frameworks worked. And almost certainly you are not using that dynamism because trying to patch your application in order to, change a dependency and rewire in a library, like that's just not something that we do. Cloud applications almost certainly are running in a container, and almost certainly that container should be immutable. And if not, there's lots of problems that that you need to be solving because you're doing it wrong. So a cloud application, if you discover a problem with your cloud application, you don't try and patch it. You rebuild it, and then when you discover the next problem, you rebuild it. That's more secure. That's got all sorts of advantages. And so in this kind of environment, your highly dynamic runtime is completely pointless. And again, there's all sorts of stuff that probably isn't needed. So it's loading classes that aren't needed, and it's doing reflection, and reflection is always expensive and slow, and it's not needed because it's in an immutable environment. And it does the same initialization on every startup, even though it's, the application hasn't changed from last time because it's running in a container. And when you look at how a Java framework starts, it actually does a lot when it starts. So there's sort of, two phases. There's a build time phase and a runtime phase. At build time, there's a process of turning the Java code into bytecode, and then there's a packaging process. And then everything else happens at runtime. So there's a whole bunch of loading and parsing the config files, parsing the properties, reading the YAML, reading the XML. And then, it does all of this class path scanning, and it looks for annotations, which can be quite slow. And then it sort of tries to load classes to see if the features need to be enabled or disabled. And then it takes all of that and it constructs a meta model. And then eventually you can do your actual starting of the application. So things like thread pools and IO. And that's so much just to get ready to start. And the question that the Quarkus team asked is, wait a minute, what if instead of doing all of that at runtime, we did it at build time? That means the start phase uses way less memory and it's way faster. And so Quarkus makes this closed world assumption that you do more introspection at build time because you assume that things aren't going to really change a lot at runtime. And this has a number of advantages. It enables native compilation because you've already done everything at build time. But even if you don't use native, you're actually still better off. So people talk a lot about native compilation because it's so cool. It is not for every situation. Even if you don't need native, you're going to get those benefits with Quarkus. It's just, it's faster and smaller. But what if you don't care about performance at all? Well, there's another huge benefit of Quarkus, which we call developer joy. And this is really about, not about the performance numbers, not about the cost savings. It's about the experience of using Quarkus. And I don't know if you can read that. It's pretty small. But what we tend to find is, people switch to Quarkus and they go, this is so good. I'm never going back because I am happier. And this is partly a side effect of the way we do more upfront. Because you're doing more upfront, you can do a lot of cool introspections of the code. You can understand what kind of programming models are being used. You can understand what's available. And then that means that actually developers need to do less typing. So let me show you what Quarkus looks like to run. So I'm going to go, first of all, actually, I'm just going to close the old one and the old one where I was practicing the demo. So let's go to code.quarkus.io. So this is a useful starting point to the network is a little bit shaky. So luckily I don't need very much network, but I do need a little bit of network. So I can scaffold a Quarkus application. I'm going to just choose the top one, which is Rest Easy Reactive. I'm not actually using reactive, but Quarkus has a reactive core, and that is exposed in the names of some of the dependencies. We realized that was incredibly confusing, so we're now doing a renaming process. So in a couple of versions, this will no longer be called Rest Easy Reactive, but I'm going to take Rest Easy Reactive and I'm going to generate my application, and then I'm going to download it. And then I've got it scaffolded. And so I can take that and let's open it in my IDE. So what I've got now is I've got my application. And so, of course, it's easy to make an application if you just download it from the internet, but there's not actually that much in here, which I think is a good thing. So I've got a Docker folder with some Docker files, because we talk about Quarkus as Kubernetes native Java, so it's really designed to be cloud friendly and Kubernetes friendly. So it comes with a Docker file. It comes with one file, a greetings resource, and then it comes with the tests, because tests are important. So let's start this. So if I do Maven, let's make that bigger. No, let's not make it smaller, let's make it bigger. Let's do Maven Quarkus dev, and let's make this bigger too. So it starts up, and this is our development mode. It does live reload. It also does continuous testing. So in order to enable it running the tests, I'm going to hit, whoops, I'm not going to hit R there. I'm going to hit R there. Now it's going to run my tests. It uses a clever sort of reverse code coverage so that it knows what code affects what tests, so that when you change the code, it only needs to rerun the affected tests. So I've got my application, and I can go and I can try it out. And let's make that a bit bigger. So I've just downloaded this from the internet. I don't know what my endpoints are. One of the things that it comes with, which is sort of handy, is just a little static page. So I can go there and I can get my application. I can also go to a dev UI, which is quite handy. And so here it's giving me a panel for each extension that I have running, and then I can do things like look at my endpoints. So let's make this a little bit more exciting. So let's make it interactive. So let's put in a query parameter. Oops. Okay, and so now if I then take that, whoops, and put in my name, then cool. So now if I go to my endpoint, hello null, because I didn't specify a name. If I do hello Fred, I can change it. So I could say yo, and then that would be yo. Cool. Now you'll notice, or if you're paying lots of attention, you might have seen that there's now red in the console because I've changed the code, and I had a test. So it's expecting that exact string. I don't really care what the exact string is, so let's just make it a little bit more flexible. So let's do contains string, and let's make that yo, and then let's import that. And then we should be cool. So now at the bottom here, you can see my tests are green. So let's make it a bit more exciting still. So this is still just, a simple REST application. Let's put in a bit of persistence. So Quarkus has lots of extensions, and it's got a CLI that allows you to add them. Because one of the probably the more complex things that came with my scaffolded application is a POM file. I don't really want to be editing that by hand, and I don't really want to be worrying about versions and that kind of thing. So I can just do Quarkus ext add, and I'm going to add hibernate panache ORM, and I'm going to add JDBC Postgres. So if I add that, oops. Let's just try panache ORM. Let's try panache. And now it should tell me, yep, thank you. Yep, so it's hibernate ORM panache. So let's do Quarkus ext add. And then let's also make sure that, I don't know if it did the JDBC or if it just errored out. So if I do JDBC Postgres, cool. So I've got my two extensions added. So now what I can do is if I go back to my greeting resource, I'm going to make a new class. I'm going to make an entity. So I'm going to do a new Java class, and I'm going to call it greeting. And this is going to extend panache entity. And so what panache is it's a layer on top of Hibernate that gives you, again, it's just about that developer joy. So it gives you lots of shortcuts. It does lots of things for you. So because I'm extending it, I'm getting a whole bunch of classes for free. And so I'll just add my entity declaration. And then I'm just going to add one field, which is a name. And now if I go back to my greeting resource, what I can do is I can make a greeting and then I can persist it. Now you'll notice I've just written to the database in a get method. So I'm going to add an @transactional to make sure that works. And of course you shouldn't be writing to the database in a get method. I should be using a post, but it's much easier to test when it's a get method. And we can pretend that this is sort of an observability mechanism that I've just written, not that I'm actually changing the database. So now if I go back here and if I run this, it's exactly the same. So that's kind of good because it shows nothing blew up. But I don't really know if what I've done has worked. So let's add in another method. So let's add in another method on the names path. And here what I'm going to do is I'm going to read from the database. And so I'm going to read from the database with the list all, and then I'm just going to turn it into a string. So here you're starting to see some of the benefits of the panache, because that list all method, I didn't write that, I just managed to inherit it. So if I go to here and I do hello/names, then it hasn't seen anybody. So if I go back to there, and I do Fred, and then let's do Jane. Let's make that bigger still. Then if I go back here, we've got the record of who I've written. So what's going on? What it's doing is it's using Panache to help with the Hibernate code. It is then writing it to a JDBC, via JDBC to a Postgres database. But I didn't actually start a Postgres database, and it is using Postgres. It's not using H2 or something else in memory. And we can see that it's not using something in memory, because if I go back here and if I do, so I'm using Podman, and so if I do Podman PS, I've got this Postgres container. But maybe it's something that I just did ahead of time as demo prep. So if I kill that, then if I go back here, and that is not a happy server, because I've just taken away the database. So what it had done is it's something that we call dev services. So the idea is if it sees that you're using something like a database or Kafka or whatever, and if you're in dev mode, it will just start it for you. So if I go back here, it does almost everything dynamic. In dev mode, it does live reload and that kind of thing. It won't cope with me killing the container underneath it, so I do need to restart it. But then if I restart it, then if I go here, oops, that was a bit too quick, then we've got that with an empty database. And so I can do things as well, like I can make an import.sql script, and then it will automatically load that if I don't always want to have it empty. So actually, yeah, let me quickly show that. So if in my resources, I can make a new file and I will call it import.sql, and then put in just a little bit of initialization script to populate the database, which is quite useful for testing as well. Then if I go here, then I've got that populated. So I mentioned already, we've got reactive in lots of the names of our libraries. A lot of the Quarkus team are really skilled with reactive. We use reactive in the core of Quarkus to give us the scalability. If you don't want to use reactive, and you probably don't, because nobody wants to use reactive because reactive is hard, you don't have to use reactive. Most people who are using reactive don't use reactive. So just to, again, sort of to reiterate what we saw in the demo, the continuous testing means that the tests run on every code change, that what you get live is what was changed. There's a developer UI. There's a beautiful zero config integration with test containers. So if you're using test containers without Quarkus, like, it's still really cool. It is still an awesome product, but there's a lot of code. With Quarkus, there is no code. Although probably realistically, you would want to have some config to say, well, if I'm in production where I'm not going to run my database in test containers, this is what my production database would look like. And then you can specify things like how you want your database to behave if you care. We call this dev services. It will auto provision all kinds of things. So like Keycloak, Elasticsearch, Kubernetes, Redis databases, whatever. In general, the way we do things is that we are opinionated in order so that you don't have to have the boilerplate. So it's more opinions, less boilerplate. So for example, the way that you used to have to do logging is all of that. With Quarkus, you can change it to just use the logger. With query parameters, that's the old way of doing it. With Quarkus, you could just do that. If you are using Spring, you have to have code to declare your application. With Quarkus, it's just gone. And again, Panache, it will save you a lot of code. So if you're using a DAO pattern, your code goes down to that. If you're using an active record pattern, again, it's quite a small amount of code. And, we've done this sort of every programming model that we've integrated with. We've really tried to get rid of the boilerplate. So with gRPC, for traditional gRPC, you need that. With Quarkus, it's just that. This is really cool. I think some people get really annoyed by this. So I did a tweet a while ago about the logging, and I got so many people who said, this is terrible. This is the worst thing I've ever seen. Because, some people don't like magic. One thing, I think the reason a lot of us don't like magic is we assume that it's going to slow our application down. Because of how Quarkus works, it's doing that enrichment at build time. So Panache, for example, does a lot of enrichment at build time, which is what allows it to get rid of the code. So there's not the performance drag that there is with some other kind of magic frameworks. For some people, they still don't like magic. That's fine. You can do everything the old way. It still works, but you don't have to do the typing unless you want to. We had a question earlier about migration. There's a couple of options that are pretty easy. One is there is tooling to help you with the migration. The other one is if you just want a compatibility library, we've got a bunch of Spring compatibility libraries, and you can put them in. And my colleague Eric DeAndrea has a video that you might find interesting where he changes out the libraries, he doesn't change any other code, and then the application runs faster, which is really cool. The one caveat there is he does have to change the tests. So the Spring compatibility libraries help you with your main code. The test model is different, so that does need rewriting. But what we do find is that people get to grips with Quarkus really quite quickly, and they get productive really quickly because we've really tried to optimize for that developer experience. If you're one of the cool kids and you're using Kotlin, then that's fine. If you go to quarkus.io and then go to extensions, you can browse extensions. We've got a Kotlin integration. I want to talk about one last thing because I think it's possibly one of the most important ones, which is the planet. Obviously very important. When I joined the team, we sort of already knew that Quarkus was super lightweight, that it was fast, but we didn't really know, does that actually translate into being greener? We kind of thought that it did, but we didn't have any evidence. So I set out to gather some of that evidence. I'm just going to give you a quick digression into how you measure carbon. The first step to measure the carbon of your application is that you have to measure the power consumption of your application. You can do that in two ways. You can either measure it at the wall if you want, or if you can, it's usually easier to just do it programmatically. So Intel have some instrumentation called RAPL, and you can use that. If you're running in the cloud, you do not have access to the wall, and you don't even have access to RAPL, because the cloud is a black box. That's the kind of the beauty of the cloud, but it makes it a pain for this kind of thing because it's inaccessible. But what you can do is, if you have access to load information, which you probably will, even in the cloud, there's a data set by a company called TEEDS, and you can translate from that data set to your power consumption. The Cloud Carbon Footprint plugin for Backstage uses this data set. And so we'd already done an experiment a while ago where we wanted to see how Quarkus behaved, like not just in a benchmark for a really short time, but how did it behave over time. So we ran an application for 20 days. And the reason it was 20 days was after 20 days, my colleague got the cloud bill and went, okay, that is the end of that experiment, and shut it down. But he had an application running on a legacy cloud native framework, Quarkus JVM and Quarkus GraalVM. And he was able to run with a much smaller instance with the two Quarkus instances, which translated to lower cloud bills. But we were able to use that TEEDS data set to see that it also translated to lower carbon footprint. So with Quarkus, the footprint was about half of what the footprint was with the other framework. And sometimes people say, well, I really want to use Quarkus because it's really cool and it's really fun and it's nice to program with. My management isn't going to go for us doing a change because change is, scary. This can often be a useful conversation to have, to say, look, we're going to have our carbon footprint if we do this. So this data set was useful, but we wanted to do some more precise measurements. So in our lab, we did the Intel RAPL instrumentation, and we measured the legacy framework on JVM, legacy framework on Graal, legacy framework on, Quarkus on native and Quarkus on JVM. And on this chart, the lower lines are better. So the higher lines are worse. One interesting thing is that native in both cases had a higher carbon footprint. That was surprising. And native on the legacy framework had a really high carbon footprint. The reason it has such a high carbon footprint is because it has a really low throughput. And so that throughput means that you have to run more instances in order to be able to meet demand. And so then that translates into a higher carbon footprint. So overall, what we see is Quarkus will cut your carbon footprint by a factor of 2 or 3. If carbon is the thing that you're trying to optimize most, be cautious with native. In some circumstances, it will have a lower carbon footprint if you haven't got much load. If you have a lot of load, which is how we were driving it in that experiment on the previous slide, you will be better off with JVM. And I said that was the last thing. One final thing is Quarkus is open source, of course, and we have an amazing community, so I just want to give a shout out to that. We give t-shirts for every release. That's, you can see mine. I joined before Quarkus 3, so I've only got the 3 t-shirt, but there's about 900 contributors, and you can see their work in Quarkus Core, and then you can also see a huge amount of their work in the extensions that people have contributed for all sorts of things. So to wrap up, if the TLDPA didn't pay attention, Quarkus gives you this frictionless development experience combined with a really high deployment density, which gives you the lower cloud bill, and it's greener. And in terms of the developer experience, you've got the auto provisioning of the services, you've got the zero config live coding, you've got the continuous testing, and you've got the developer UI as well, which a lot of people really like. If that was still too much, then you can just remember the T's of, in terms of what problem is Quarkus solving. We are solving the problem of excessive T consumption by English developers. We are solving the problem of excessive typing by all developers. We are solving developer tedium. We are solving that tax that you're paying for dynamism, and you're solving all the treasure that you're giving to the cloud providers because your applications use so many resources. And with that, thank you very much. I think I have finished exactly on time, so I don't think I have time for questions, but I'll be here for the rest of the day, and the slides are available there as well. Thank you very much.